Let's take a look at this very interesting question on page 53. And one look at this question, I know it's a minima-maxima problem because it stated that we need to find the value of t for which the distance is a minimum and later find minimum distance. But first, let's solve for part I. Find the expression of our distance between A and B t seconds from the start. First of all, where is A and B at the start? According to the question, A starts from P and B starts at Q. Now then we ask ourselves the next question. Where would A and B be t seconds from the start? So we know that A has a speed of 40 meters per second and B has a speed of 3 meters per second. Hence, after t seconds, where would A and B be? We also know that A moves from P to O and B will move from Q to O. Hence, after t seconds, B will be 3t from Q and A will be 4t from P. Now then, how will we find the distance between A and B t seconds from the start? This is indicated with the gray dotted line. The hint will come from this. It's a right-angled triangle. So what we can think of is Pythagoras theorem. And Pythagoras theorem states that a squared plus b squared equals c squared. Let's write the equation. So because of Pythagoras theorem, AB will be as such. Now I just need to expand whatever that is inside the square root term and simplify it. The final answer will be this distance. Now after finding the distance, I need to do part 2, just to find the minimum distance. And when you say minimum, you must immediately think of my stationary points. Where in this case, d over dt will be equal to 0 because it will be a stationary value. So with that, what should be the first thing that you do? I will use my equation from part 1 and I will differentiate it. Notice how before I differentiate it, I will try to simplify it, meaning my square root term is power half. And now we shall do chain rule. Bring power down, power minus 1, differentiate terms inside. This will be my first derivative using chain rule. Now, what will you do? Remember, since we are finding minimum distance, my first derivative will be equal to 0. Once we equate the first derivative to 0, we'll just follow what the question wants us to do. Find the value of t. And t will be equal to 5.2. Even though the question says that the distance will be a minimum, but I must still prove that it's a minimum. How to prove? Use your first derivative or second derivative. If you look at my first derivative over here, is it easy to differentiate it? Since it doesn't seem very easy to differentiate it one more time, I will just use first derivative test. After doing the first derivative test, I have proven that it is a minimum value. So indeed, the distance will be minimum at t equals to 5.2. And my very last step is to sub in t equals to 5.2 back to the original equation for distance. And I'll get minimum distance 2 meters. We have come to the end of the video.